I'm Anil Kumar sharing with you a very interesting question on rate of change, application of trigonometric functions. Question number 3. A line L through point 0,1 is rotating about point 0,1 at the rate of 1 revolution per minute in clockwise direction. At what rate is the point of intersection of L and the x-axis moving along the x-axis when x equals to 5? So let's sketch this to understand the situation and then we'll figure it out. So we have a line kind of like this, which is rotating about a point 0,1. So that's your y-intercept. This is the point 0,1, right? So 0,1. So when it rotates, it's rotating in clockwise direction. It's rotating in clockwise direction. So the rotation is given to us as 1 revolution per minute. Now this will be considered negative since it is clockwise, right? Since it is clockwise. Is that clear? So 1 revolution per minute is the rate of change of angle. So if I say that this angle here is theta, let's keep this angle as theta. In that case, what we are saying is that d theta dt is equal to 1 revolution means 2 pi. So I can write this as minus 2 pi radians per minute. Correct? So that becomes d theta dt. Now we want to find at what rate is the point of the L and the x-axis. Let's say this is the x-intercept. So this point is moving. Let's call this point as A. When x is 5, when this x is 5, that is what it is. We know this is fixed at 1. Let's also calculate, let's call this point as B. So what is AB equals to? Let's write down here. AB will be square root of 1 square plus 5 square. Correct? That is AB, hypotenuse. Okay, so which is square root of 26. AB. Okay. Now, we can relate, let's say this is x anytime, right? If this is x, in that case, how is x related with theta and 1? So that becomes the opposite side, correct? So that is the opposite side. So we can say tan theta is equal to x over 1 or x. Is it okay? X over 1, we can say that. Now, let's differentiate both sides with t, right? So let's differentiate with respect to time. So if you do that, you get secant square theta d theta dt equals to dx dt, correct? We actually need to find dx dt when x is 5. That's the whole idea, right? So we need to find dx dt when x equals to 5. This is what we need to calculate. So that's what it is. We know d theta dt is minus 2 pi. And for the given angle theta, what is secant theta? Well, secant theta will be hypotenuse over adjacent side. So in this case, secant theta will be hypotenuse square root 26, right? Over 1. So secant theta is square root 26. So we know this. We're going to substitute this here. So substituting, we get square root of 26 whole square. D theta dt is known to us as minus 2 pi, which is minus 2 pi, is equals to dx dt. Correct? So that is what it is. Now, we can just multiply this, and that is 26. Right? So we get minus 52 pi equals to dx dt. Does make sense, right? So that is what it is. The units will be, well, we are not given any units along this side per minute. So, okay. So whatever units per minute. So we get our answer, which is the rate of change at this instance of time will be, it is decreasing, right? That negative means decreasing. Minus 52 pi units per minute. Okay. So that is how we are going to solve it. I hope it is absolutely clear. Feel free to write your comments and share your views.